Hey guys. Okay, so today we were talking about equivalent ratios. Yesterday I gave you just kind of the basics of ratios, and today we're going to start moving into when two or more ratios are equal to each other and different ways that we can um, find equivalent ratios. I have this like a pointer thing with a pen, so I'm going to be trying to write on the slide, so bear with me. Also, you can maybe see Moon behind me right now. I'll try to have Alexander Hamilton make an appearance later. All right, so just go ahead and write down two equivalent ratios that you can think of for 3 to 5. I'm going to start off and write 1. Switch to a pen. So one equivalent ratio that I can think of that is equivalent to 3 to 5 would be 12 to 20. Take a second and try to write one more on your paper. All right, I'm going to write my other one. We'll go ahead and do 6 to 10. All right, so take about 30 seconds here and brainstorm how many different ways you can think of to find equivalent ratios for the ratio of 2 boys to 3 girls. And while you do this, go ahead and pause the video. Okay, so I'm going to tell you about 4 different ways of finding equivalent ratios. The 4 ways are equivalent fractions, multiplication, tables, and a tape diagram, which is where this handy little drawing on the PowerPoint is going to come in handy. Go ahead and pause the video anytime you need to write down what I'm writing or to take down the notes. Okay, so example number 1 is using fractions. So the ratio I'm giving you is that the length of Shani's ribbon to the length of Mel's ribbon is 5 to 3. How much, let's make this magenta, how much ribbon does Mel use if Shani uses 45 centimeters? And the way that we work this out is we can set this up like a fraction. We can do 5 over 3. We need to make sure that we know that this is Shani. What's happening there? And that this is Mel. All right, so this is our original ratio. Shani uses 45. Now, it's really important when we do equivalent ratios as fractions that we don't start mixing up the top and the bottom. So if this had said that Mel uses 45, then I would need to put the 45 as the denominator, oops, not the numerator. So we're going to do, that's an S, not a 5. Okay, so this is an S. And then we need to do, like, what do we do to get here? So, using equivalent fractions, we know to get from 5 to 45, we have to multiply by 9. And whatever we do on the top, we have to do the bottom. So, to understand how many meters, of ribbon Mel uses, we have to do the same thing that we did to the top to the bottom. So you have to multiply times 9. 3 times 9 is 27. So Mel uses 27 meters of ribbon. So that's how we can use equivalent fractions. It is possible to set ratios up as fractions. You just need to be very, very, very cognizant of which one you're putting as the numerator and which one you're putting as the denominator, and you can't switch them around. Okay, so multiplication. We kind of already did this with fractions, but we're just presenting it a different way. So the ratio of number of laps Mason ran to the number of laps Laney ran was 2 to 3. If Mason ran 8 laps, how many did Laney run? So we have 2 to 3 for our original ratio. Mason ran 8 laps. And how many did Laney run? So for this, 2 times 4 equals 8. So we have to do the same thing for this side of the ratio. 3 times 4 is 12. So that means Laney ran 12 laps. Okay. If Mason ran 8 laps and their ratio was equivalent, which would be 3 miles, because 1 mile is 4 laps around a track. Oh, also the reason I look like this is because I just got done with boxing class, so sorry. Sorry, I'm not sorry. The ratio of number of laps to Mason, the ratio of the number of laps Mason ran to the number of laps Laney ran was 2 to 3. So now we are going to use a table to make more equivalent ratios. So draw this out on your paper. Everything I'm writing down, you need to be writing down on your paper. All right, so our original ratio is 2 to 3. And let's go ahead and make this a table. So we need to list out 4 more equivalent ratios. This is one way that we can do this. And guys, all of this is just really using multiplication and division. All right. So this is what? Mason, and this is Laney. All right, so let's say 2 times 2 is 4. So if Mason runs 4 laps, 3 times 2, 6. Laney runs 6 laps. If Mason runs, let's do 2 times 3, 6. So everything I'm doing up here, I'm just multiplying. 3 times 3 is 9. So if Mason runs 6 laps, Laney runs 9 laps. Okay. Let's do 2 times 5 this time. 2 times 5 is 10. If Mason runs 10 laps, 3 times 5 is 15. I'm going to add another box on here, so we have to do 4 more. Or 4 total. And let's do 10 this time. 2 times 10 is 20. 3 times 10 is 30. This is where like doing those multiplication tables comes in really, really handy, and just be able to know your facts like off the top of your head. It makes this kind of thing become really fluent and really easy for you. You can just look at something and see the ratio right there and see the equivalent fractions right there. Sorry. Okay, so tape diagram is a way to visually represent the breakdown in comparing the parts of the whole or parts to parts. So it's a way to visually represent ratios, and then we can let pictures kind of stand in for our numbers. So let me show you how this works. And it's actually a really cool way to do this once you know what you're doing. Change that to magenta. And do pen. Okay, so a tape diagram is where you make rectangles or squares to represent the pieces of the whole that each part has. So let me just draw it instead of trying to explain it. So this is Mason. He runs 2 laps. So we're going to draw a square for each lap he runs. For each lap that Laney runs, he runs 2 laps and she runs 3 laps. So for every 3 laps that Laney runs, Mason runs 2. For every 2 laps that Mason runs, Laney runs 3. So we can use this to represent like parts of a whole. Like this here could be 1, 2, 3. She runs 3 laps. He runs 1, 2. Or each one of these could represent 2. 2, 4, 6. If she runs 6, he runs 2, 4, 4. If she runs 30, so we split that up into 3, 10, 20, 30. Each one of these blocks represents a 10. So this would be 10, 20. So you can see that on the last table that we drew. So if she runs 30 laps, he runs 20 laps. If each of these blocks represents 25, this would be 25, 50, 75. So then Mason would run 25, 50. So if Laney runs 75, Mason runs 50. So all we have to do, so we know Laney runs 930. Write this down. So these 3 blocks represent 930 laps total. We need to figure out how much each block represents, and then Mason gets 2 of those blocks. So what we have to do is split this 930 up into 3 parts, which is a division problem. So we do 3 divided by 9, or 3 goes into 9 3 times. 9 divided by 3. 3 times 3 is 9. Subtract. Bring down. 3 goes into 3 1 time. 3. Subtract. Bring down. 3 goes into 0 0 times. 0. There's nothing left to bring down. There's no remainder. Each one of these blocks represents 310 laps, which is an insane amount of laps. So each one of Laney's blocks represents 310. that means that each one of Mason's blocks also represents 310 laps. So you just add the two 310s up to figure out, or you can multiply by 2, either way, to figure out how many laps, that is a 3, Mason runs. So if you can't see that, that is 620. So Mason runs 620 laps if Lainey runs 903 laps. Oh, that's what it is. It's meters. So if Lainey runs 930 meters, then Mason runs 930 meters. 930 laps is a ridiculously large amount of running for one person to do. All right, so we're going to do tape diagram again, just to get a little bit of practice with it, because this is probably something that you're not super used to doing, but it is a really, really, really helpful way to get a visual of equivalent ratios. So in a bag of mixed nuts, the ratio of walnuts to cashews, so you have walnuts to cashews, is 5:6. And because walnuts is mentioned first in our ratio in the sentence, that means that the first number is walnuts. So I'm going to draw 5 blocks for my walnuts. And cashews, I draw 6 blocks. All right, so we know that there are 54 cashews in this bag of nuts. We'd figure out how many walnuts there are if this ratio stays as 5:6. So we have 6 blocks here. We have 54 cashews. We just need to split these 54 cashews up and figure out how many cashews are represented by each box. So to do that, we just do 54 divided by 6, because there's 6 blocks, which is, of course, 9. So 9 times 54, or 9 times 6 is 54. All right, so each one of these blocks is 9. 9 nuts. So each one of these blocks is 9. You can add up 9 plus 9 plus 9 plus 9 plus 9, or you can just do 9 times 5. Which means that there are 45 walnuts in the bag. If there's 54 cashews, there's 45 walnuts. It's a good deal. Cashews are delicious. All right, so for example 6, I want you to actually take the time to look at this ratio, pick the strategy that works best for you. We've got equivalent fractions, we've got multiplication, you can draw a table, and you can draw the tape diagram. Pick the one that works best for you to figure out the answer to this problem. So if Josie, let's see here. All right, on a test, the ratio of number of problems, Josie got incorrect, that means wrong, to the number of problems she got correct is 2 to 9. So 2 is incorrect, 9 is correct. If Josie missed 8 problems, which would be incorrect, how many did she get right? So we know that she got 8 incorrect. How many did she get correct? Go ahead and pause the video, take a minute, figure out which one of the strategies you want to use to solve this problem. And when you are done solving it, let me see your paper, and I will tell you what task you are going to work on for independent practice. All right. Thanks, guys. I got to get Hamilton up here. Alexander Hamilton, come here. Yeah. Tommy's been training him. Oh. Come here, Ben. Come here. There you go. You got more? You got more? Come on. Up. Up. Oh. All right, I'm just going to turn the camera so you guys can see him. Say hi, Hamilton. Say hi. You speak? You got it. There you go. Good speak. Good speak. Good speak. Good speak. Can you... You spin? No. Spin? Spin? Oh, good spin. Good spin. You're such a good puppy dog. All right.